Okay. Hello, everybody. Welcome to the talk for inspecting IPTV for fun and no profit. That's important. My name is Josip. This is an advanced talk. So if there is something that you don't understand during the talk, feel free to ask me at the Q&A after, or today during the conference, or tomorrow during the conference. I'm here all day, every day. Okay, so a little bit about me. I'm currently CDO at a company called SofaScore. My interests range from security, system architecture, DevOps, and generally all things related to backend. At my apartment, at home, I have the internet. Obviously not the internet, but the internet. In that package, I also have IPTV, which is the way I consume the video content and all of the channels that my ISP provides. So the setup is something like this. There is my ISP, and it's connected to my router. And to my router, a little black box called the set-top box, or STB for short, is connected via an Ethernet cable. And the way it works is the box gets the video stream via network, and it converts that video stream to an image, a video, that can be displayed on the TV. So all of the processing and all of the logic actually happens on that little black box. And you cannot have IPTV without it. Now, a little story. So one day, I'm at work, and my wife calls me. And she says, hello, the TV is not working anymore. And my first response is, well, just turn it off and on again, and it should work. And she tells me, yeah, I tried that, but it's still not working. And I'm like, okay, I'll fix it as soon as I get home. She was pregnant at the time, so she was home. She wanted to watch the TV. And if you know any pregnant women, you don't want to get them angry, right? So you have to do what they say. So the first thing I did when I went back home was to see what was going on. And to my surprise, the TV was actually working. The channels were working, like I could watch the basic 4 channels, but nothing else, which is weird. Like, you would expect it to either work or not. You wouldn't expect it to just work sometimes. And the message I got for all of the other channels, like more than 100 of them, was this. It said, you do not have a subscription for this channel, which was weird because I know I paid my bills, the internet works, everything works, the basic 4 channels work, but nothing else. So my first thought was, well, I'll just call the support, right? They're going to handle it. So I did. And after explaining my situation, like the channels work, but most of them don't, I got the standard response, which is, did you try turning it off and on again? And I know that's the universal solution to all of the problems in the universe, right? But I actually forgot to do that. I didn't try to turn off and off on the STB. So after the lady kindly explained to me that I should do it, I asked her, but it works, just not all of it. And she said, yeah, that's fine. The STB probably didn't pull all of the information it needs to know what you should and shouldn't watch. And I'm like, what? How? Is it really on the client? Like, there isn't some central server which tells me I can or cannot do? Like, this little box is the one that does it all? Like, that reminds me awfully a lot like the code when you write it in JavaScript, which checks your username and password and then lets you go on to an administration site, right? That's not really something you would expect. So But I said, okay, I'm gonna do it. Like, I trust you, there's nothing that can go wrong. So I turned it off and on again, and it worked. So I had all of the channels that are in my subscription, which is weird. I wasn't expecting it to work. So that's something I written somewhere in the back of my head, because at the time, I didn't have the time to look into it, but I really wanted to. So fast forward a couple of months after that, my wife gave birth to a beautiful baby boy. And if you do not know how children behave when they're that young, they basically do 3 things all day, every day for the first couple of weeks. They sleep, they eat, and they poop. Nothing else. And my son had an incredibly good schedule. Like, he was sleeping 2 hours, then he would wake up, and he would eat for half an hour, and then repeat. So my wife was on maternity leave, and of course I was there to help her. And when it was my time to watch over him, I had 2 hours to do anything I wanted, because she was doing something else. And she wasn't watching the TV, which meant I could play with the TV. And that's exactly what I did. The first thing I did was open the STB and its settings, and I looked at the information available there. The interesting part is, it tells you its own MAC address, which is useful, and it also tells you its own IP address, which is also useful. The thing to note here is that the IP starts with 10. And if you know anything about networks, usually on your laptop, it starts with 192. So what this meant was, this was in a separate VLAN, which meant I couldn't access it with my laptop. I couldn't do anything with it. So my first thought was, well, I'm just gonna look at the port that the STB is connected to my router, and I'm just gonna put my laptop there. Like, that should work. I'm probably gonna get the same IP the STB did, so I can look around on the network. It didn't work. Then I thought, well, maybe it's due to the MAC address, right? And the STB kindly told me what its MAC address was. And I tried cloning that MAC address. It didn't work. So at that point, I was stumped. Like, I didn't know what to do next. I couldn't do anything with it. And then I remembered, this is the setup. Like, I have my router, I have my STB, which should do all of the processing, and in between them, there is an Ethernet cable. And what you can do, you can put a network tap between those 2 devices and see all of the traffic flowing in between. Now, network taps are fairly easy to come by. You just buy one, connect one end to router, the other end to whatever device you want, and all of the data flowing will be visible. And they're actually not that expensive. You can get one for 50 or 60 bucks. But the problem was, I needed it now, not in a couple of weeks when delivery came. And then I remembered, I actually have a Raspberry Pi somewhere. And that Raspberry Pi has an Ethernet port. It has one, but it's a start. I need another one, which it doesn't have. But luckily, since we live the dongle life, I also had this. It's a USB to Ethernet adapter, right? So I didn't know if it's gonna work. You need drivers for that. But I took a shot. I disconnected this cable here, and then put my Raspberry in between. So the cable goes to the dongle goes to USB, it's now an Ethernet port, and then another Ethernet port goes back to my router. So what I effectively did here was put a device in between and did a man-in-the-middle, I'm not gonna call it attack, but you get the point. Of course, this doesn't actually work out of the box. You have to do some stuff to make it work. So you have to, it's Linux installed on my Raspberry Pi, so you need to create a new interface, a bridge interface. You mustn't specify an IP address because you'll get that 192 address, which will mess up everything. You bridge the ports. You turn off settings that you do not want, and you set up some kernel parameters which allow for IP forwarding. And the interesting part was, as soon as I did this, the TV started working again, right? So the image appeared on my TV, and the video was showing. And it was going through my Raspberry Pi. And at that moment, I could fire up Wireshark, and I could see all of this goodness. So this is UDP. It's a real-time streaming protocol, which is used to deliver content from the network to a device. And what STB was actually doing was taking that stream and converting it to video, which is then displayed over HDMI on my TV. And I said, okay, that's nice, it's a start, but that's not really what I'm interested in. I would like to see what happens when the STB is booted up, right? That's when the magic happens. So I did that, I turned it off and on, and what I got was a set of interesting packets which are actually HTTP, which is awesome, because you know, HTTP is simple. Everybody uses HTTP, it's ubiquitous. When looking further into each of those calls, there was this call, which is actually a JSON, and it's pretty big. It's huge. And I know you cannot see there right now, but it's actually a list of all of the channels that are available, and some channels that aren't available because they're hidden, and a list of all of the subscriptions together with those channels, which was interesting because now you can see everything that's there, together with how it's streamed and whatnot. And then there was another call which told you, now this obviously isn't JSON, this is something else. It has lots of slashes and percentage signs and whatnot. But if you look at it long enough, then you figure out that there are some strings that are recognizable, that do appear in the call before. And it's actually a list of my subscriptions, things I have access to. So on that day, when my TV didn't work, what actually happened was this call didn't get through, and I couldn't watch anything, right? So that was interesting. I mean, the most interesting part was it's HTTP. Like, I know HTTP. I've been doing web development for most of my life. So it's not hard. You have your request and response, your head and body. I know what I need to do to modify it, right? So that was interesting. But you have to modify it somehow. And when you start thinking about it, it's probably not that hard. Like, I have my router, now I have my network tab, and I want to change something into something else. It should be doable, right? The kernel is already doing the work for me. I just want it to stop and change a few bytes, right? Nothing hard. Then you start thinking about it, but TCP/IP, there's a lot going on, right? So I just want this, but that's not enough, right? You have to think about checksums if you modify this. You have to think about IP checksum. And there's also the fragment offset, which is there because TCP packets and IP can come in any order, right? So you have to have them in the correct order, which complicates things. And also, because there is this offset, that's there because you have to watch for the maximum transmission unit, which for Ethernet is 1,500 bytes. You cannot go over that. That's why it fragments. If you go over that, the packet will be invalid, and it will fail. So you might use some tool that is already available, like man-in-the-middle proxy, which should work, but it relies on a couple of assumptions. You have to have an IP on the bridged interface, because it doesn't actually work with the packets itself. It's just a proxy. It receives the connection and creates a new connection, and it lets the OS to do all of the things for you. So you also have to have routing defined, none of which I have, because I don't know what's going on. I don't have the IP. And it uses a lot of CPU, which is important because my Raspberry Pi is old. So that wasn't really an option. And then I started looking, and there's this cool little feature. It's not little, in Linux kernel, called the netfilter queue. It allows you to accept, drop packets, and a couple of other stuff in user land. So when a packet comes, the kernel forwards it to user space, and you can do whatever you want with it. And you can modify it before accepting it, which is awesome. And then, I'm lazy to write my own code. There's this cool little tool called NFQ sed, which works like sed, but on NFQ, which is amazing, because you just modify the content, and it does all of the work for you. It can replace some text with something else. The only thing you have to do is create an IP tables rule for the forward chain. You specify TCP, the port, and you specify that you want to redirect it to the queue, and you specify a number. Then you just call NFQ sed. You specify that you want to replace something with something else for that queue, and it works. It works really well. So I wanted to try it out. And in Croatia, we have this national television program that's called HRT. And just to test it out, I replaced all of the currencies of HRT with TTT, just to see what's going to happen. So I did that, and I rebooted the STB. I mean, the logo is still here, right? Because it doesn't contain HRT in its name. But the text, it's changed. So that's when you start thinking, what else could I do? Like, you can replace something with something. You just have to watch that it's not bigger than it used to be, because it will fail. But you can always go smaller, right? So looking back on that list of channels, I wanted to find something I do not have, which is HBO. And as it happens, it's a fairly small string, right? HBO, just 3 letters. And then going back to the list of my subscriptions, I found something that's a bit larger, that I do not need. And going to NFQ sed, it's a simple thing to do, right? It's not complicated. You just take a larger string and replace it with this. I mean, I wasn't sure it's going to work. So I ran that. I turned it off and on again. It's such an amazing tool, turn off, turn on. Oops. It works. Like this caught me a little bit off guard. I wasn't actually expecting it to work. I thought it's gonna take a bit more. Like this, that was too simple. But you know, it works. It works because all of the metadata is going via HTTP. It's unencrypted. Yeah.
So you changed your permission, what you have,
yeah,
and not the definition of what each channel.
Exactly. I just changed my subscriptions to remove what I had and replace it with something I didn't have. So I lost the channels that were in the other subscription, but it doesn't matter. So I used Raspberry Pi for this. Like, it's affordable, but it's not the cheapest thing in the world, right? If you want to buy everything, it comes around 50 bucks to have everything. And then you have to find your Ethernet cable, Ethernet adapter, and you have to find one that works. There's a whole section on Raspberry Pi wiki dedicated to just what chips are available. right? So what I did, I Googled, and I found this awesome little board that has 2 Ethernets built in, it has a Wi-Fi, it has 256 megs of RAM, and a quad-core CPU. This thing is so obscure, you don't have the case for it. I had to 3D print it. It's that obscure. And it costs just $13.90 for this. It's amazing. Like, you can do whatever you want with it. You can do this, you can build your own firewall, whatever. I actually have 3 of those here, so for the questions after, I'm gonna give them away. Together with the case, so you get one, right? So this was a simple replacement, right? 1 packet, we were lucky. It was not encrypted, it was not compressed. The resulting packet that we wanted was less than the MTU because we were going with a string that's smaller, and we could use existing tooling for it. It was a fairly simple thing to do once you have all the pieces. But what if you want something more, right? So what if you want to change data that is compressed? You can't, because it's different every time. You cannot do a search and replace for compressed data. You have to replace the whole packet and then some. If you have encrypted data, you might know the key, but still, you cannot do a simple replacement, right? So if you have multiple packets that you want to modify, such as you have when the data is compressed, you can do it with simple tools. You cannot increase packet length. You could increase it, and then the overflow could be shifted to the next packet and the next packet and the next, but you cannot do that with simple tools. So if you could do it maybe in some programming language, like Python, you could do stuff, you know, more complicated stuff. Turns out you can. There is a library called netfilterq, and if you combine it with Scapy, which is a library for manipulating packets, which is awesome library, you can do a lot. So the code is still fairly simple, right? You create a queue, you bind to a queue with the number 0 or whatever, and you give it a callback. And then every time that IP tables redirects your packet to your code, this gets executed for each and every packet. So what you want to do is you remember the length of the packet before, you replace what you want to replace, you delete the checksums, and Scapy is so good, it will calculate them for you, which is awesome. And then you just recalculate the length. It won't do that for you, unfortunately. But it's not hard. And then you just set your payload to the new string and accept. And that's the equivalent of what we did with NFQ set. Like you're replacing one thing with another, but you can increase your length if it's smaller than the MTU. Now this is simple, this is nothing special, but since it's a programming language, you can create a list, and then you can save multiple packets to that list until that time that some condition is met. So you can have 1, 10, 100, 1,000 packets, and then when you get, for example, all of the compressed data, all of the packets, you can simply sort those packets, decompress them, change whatever you want, compress them back again, and then put it in the packet in the right order, and then just accept all of the packets at once. You can do this for anything you want, not just compressed content, but also encrypted content, or content with any kind of logic you want. You can do ifs, if something, then replace, otherwise not. You can increase your compression rate and then put more data in, because usually the compression is not the strongest one, right? So you can do a lot. You can basically view and modify any packet without knowing anything about the network, like IPs or routing. And the best part is the MAC address in the packet doesn't change. So nobody knows what's going on, right? not the STB, not the router, not any other device that there is. And that's it. For that, the code could get complicated, but it can be done. Thank you.
Thank you, Josip. I have a feeling there will be questions. We do have time for one, and then you'll have to catch Josip afterwards because we have to stick to the schedule. So who was first? Okay. Do you want to fight? I don't know.
I assume the provider was Telemach, or who was
What?
it? Who was the provider, the ISP?
I won't answer that question,
Okay.
but
Doesn't matter.
all of them.
Doesn't matter.
I checked all of them.
Anyway, I was wondering, do you have an idea of does it make sense for you to give up on this hack and tell the provider for a reward?
I tried.
They didn't care.
No.
Oh, that's
You know, standard reply from ISPs. It's fine.
Okay, one more very quick question. He was faster, sorry.
So all of this traffic is just plain HTTP, not HTTPS, not actually encrypted.
Nope.
Yeah.
Nothing is encrypted on any provider, which is they don't actually do it themselves. Like they buy the hardware and the software. I don't know why it's hard to do HTTPS.
So
obviously.
they actively do not care.
Yeah, and I mean I didn't talk about it, but the thing is even worse, right? The box checks firmware on every boot, which is also not encrypted and probably not signed. So you can just replace that and flash whatever you want. If you can extract, you can do a lot of stuff.
Yes, thank you. I noticed in the very beginning that it also downloads a certificate, actually. So what's the point of that? And did you bother to replace it by something else? Or because
No.
maybe you could descript the streams or something with it? Or?
Yeah, no, there is a certificate at the beginning. I guess it's used to verify the firmware, which makes no sense. But you know, a lot of things don't make sense. You cannot do any damage to anybody, but it's fun to play around with it. You can do a lot of stuff for your TV.
Thank you, Josip.
Thank you.